Hello, I'm Margherita Polacci and I'm a senior lecturer in volcanology at the University of Manchester. And today I'm going to show you some of the most important results that we have obtained investigating the magmatic and eruptive dynamics of basaltic systems, particularly focusing on Mt Etna in Italy. We have combined an environmental cell with fast X-ray computed magnetotomography to run in situ time-dependent for decrystallization experiments of clinopyroxenes, oxides, and plagioclases at diamond light source in the UK synchrotron in both hydrous and anhydrous Etna basalts at high temperature and either ambient or intermediate pressure. The results of the experiments highlight some important points. First of all, this equilibrium crystallization is ubiquitous. Then crystal nucleation and growth occur in pulses, and they occur throughout the length of the experiment and not just as a single-step process. We have observed suppression of crystal phases due to time and temperature, and dendritic crystallization as a function of increasing undercooling. The results of these experiments have a big impact on magma rheology and important implications for magma mobility, eruptibility, and solidification on the surface. The results of the 4D tomographic experiments, such as crystal growth rates of plagioclases and pyroxenes, have been fed into a numerical model of the physical behavior of magma in the conduit to understand and constrain conditions leading to magma fragmentation in basaltic systems. And these conditions are a temperature lower than 1100 C, a synerupted crystal volume percentage larger than 30, and a viscosity around 10 to the 5th Pascal second, which means that every basaltic system in the right conditions can fragment brittly and produce a plinium basaltic eruption. This has huge implications for hazard assessment and risk mitigation in volcanic areas. Finally, we have started a new phase in our investigation of basaltic systems by using a new X-ray transparent internally heated pressure vessel to run in situ 4D vesiculation and crystallization experiments at high pressure up to 250 megapascals and high temperature up to 1200 C. This apparatus allows us to reproduce, visualize, and quantify these processes at real magmatic conditions. We have just finished the first beam time using this apparatus at I-12 of diamond light source this past December 2021. This beam time was dedicated to vesiculation experiments on Etna basalt, on hydrous Etna basalt at water saturated conditions. Thank you very much for your attention.